Hello, welcome to another episode of the Weekend Algorithm. This is Higher Code, and if you are coming across this channel for the first time, please I want you to subscribe to this channel, give this video a thumbs up, and also ping that bell icon so you always get notified. And even if this is not your first time of coming across this channel and you are yet to subscribe, please just do so as to support the channel. Now, today's episode of the Weekend Algorithm, we have a problem right from hackerearth, algorithmic problem, and the title of that problem is Find MEX. So let's take a look at what this problem is really all about. So I'll scroll back to the top, and the problem goes like this. You are given an integer array of length n. You have to find the MEX of the ith element for all 1 is less than or equal to I, less than or equal to n. Now the MEX of the ith element is the minimum element greater than or equal to 0 which is not present in the array till the ith index. Now the input format goes like this. First line contains an integer n denoting the size of the array, and the next line contains n integers denoting the elements of the array. Our output format is straightforward. We print n integers element. I element should be the MEX of the array prefix Ti. So yes, I will explain this in much more detail when we get to the explanation section. Now our constraint is 1 is less than n, which happens to be the size of the array less than or equal to 2 times 10 to the power of 5. So this is our constraint, and we'll be making use of this constraint value in our program. And here we also have 0 is less than or equal to the value of the array at any index, which is also less than or equal to our given maximum constraint. And our sample input, for example, is 5, which is the size of the array. Then we have the different elements of the array, which is 1, 0, 5, and 5, 3. And our sample output is 0, quadruple 2. And yes, the explanation goes like this. For first test case, MEX of first index is 0, as it's not present in the array, as it is not present in the array. This should be not note. And MEX of second index is 2, as 0 and 1 is present in the array already. And MEX of third, fourth, and fifth index is also 2, as 2 is not present in the whole of the array, and 2 is the minimum positive value. So let me explain. At this particular point at index 1, using an indexing system of 1, only the value at this point is 1, and the only positive value that does not exist yet in the array is 0. So that's why we have 0 here. But at index 2, we have 1 and 0 already present in the array. So the only next positive value that is not present is 2. And it also applies to this point, which is 5, 5, and 3, because 2 is the minimum value. So we have to keep on printing out the value of 2. So without further stressing, let us look at the algorithm to implement to achieve a proper and efficient solution. So I have an image right here already that describes the algorithm. Now we have to read the elements from the input source, and 2, we create a static variable, an array of type boolean with size equal to the maximum given constraint plus 1. There's a reason for adding 1 to it, and that is due to we are making use of an array, and we have to access all the index of the given constraint. Now we initialize an int variable that represents the current MEX value and also its index. We look through the array, and for each value in the array, we get the value at that index, and initialize the boolean array and initialize the boolean array of that particular value index. So At this point, we get the value at the index and we take the value, assess the index of that value in the Boolean array and equate to true. So this should actually be value and not just the index. Now, if the value equals current MEX, we update the value of current MEX using the find MEX function, and then we print out the value of current MEX. So let us look at find MEX also. I think it should be back here. Yes, we have find MEX. Let me just zoom in a bit. And this is how find MEX work. For each element in the Boolean array, if the value at that particular index is false, just return that index. We have successfully located the next MEX in the series. S, continue with the normal flow of the program, increase the index, and at the end of the day, if such value is not found, just return 0. So we have seen the algorithm to implement. Let us jump right into IntelliJ. So right here on IntelliJ, we have a couple of classes, and I have finding MEX. And when we move over to this, we have finding MEX with StringBuilder, finding MEX with scanner, and also we have finding MEX with string. We'll be looking at each of these classes. I'll be running a test case against each of these classes. As you can see, I already have the code. I don't want to waste your time and start coding everything, but I have a default class that was just given the name of finding MEX. So I'll walk you through the implementation of the program with this default class known as finding MEX. So for a start, we have a static Boolean array variable that is a member of the class, and the name of this array is called is found. And we have initialized and given it a size of 200,001. That is the given constraint plus 1. The given maximum constraint plus 1. Now to find the minimum element that is non-existing in the array, I have a find MEX method. This method or function takes in an int variable, an int value, which indicates the start index. So it starts from that index and search through it reads through the isFound array, and immediately it checks that a particular index is having a value of false. It returns that index. Yes, it continues with the normal flow of the program, and at the end of the day, it's going to return the value of 0, which in this case, the program is not really going to encounter a case like this. Now, looking at our main method, we are using a buffer reader for finding MEX at first. I won't be testing against this class, I'll just be testing against this other 3 class. And yes, right here we read from the input source. We also use the StringBuilder. I did this for finding MEX because it was the most efficient when I checked when I run the program. Now looking at its number, we use the Java Stream API to split the array, to split the numbers string value that was read from our input source. Using the Stream API, we converted it to an array of ints. So we have initial MEX, which is 0 for a start, and we also have a variable called found of type int, and this variable indicates every number that is inside of our array. So immediately a number is seen in the array, we are going to say found is equal to that number, and then we set is found at the index of found to true. So this is how it works. Immediately we have for example a value of 1 from the given array. We take that value, which is 1, and initialize the index of is found on that value to true, and then we check to see if initial MEX is equal to found. And if initial MEX is equal to found, then we have to look for the new MEX. initial MEX should be our start index. So I want you to just take your time, study the program, and see how it works. Now, starting with testing, we have to start with finding MEX with scanner. And I've highlighted all of this already. I'll just Control C to copy, and let us jump to hackerearth. So right here I have Java 14 Oracle 14 already, and I'll paste the whole of the code on this console, and I'll compile and test. Okay, sample test case passed. Now it's time to submit the code as well. Okay, now the total time it took for all test case to pass was 6.96 seconds, which is approximately 7 seconds. So what is happening right here is that I am using the scanner class to read my input, and in addition to that, for each initial MEX that is found, for each initial MEX, I'm also printing the value of initial MEX at inside of the for loop. So this simple print clear statement also executes when this for loop is executing. So for each initial MEX, it's always going to print at the value. So let's jump to IntelliJ and copy the whole of the StringBuilder implementation, and that should be okay. Find MEX to StringBuilder, and I'll do same thing, Control A, C, and then I'm going to highlight the whole of this again, and I'll paste the one of StringBuilder. So this time around, what I did is I'm using a StringBuilder to append all the initial MEX, and at the end of the day, I just print out the builder, the value of the builder just once, instead of repeating the same system to add a print line statement over each iteration. So no need to compile and test, I just have to submit the code. And this time around, our program has reduced, the time it takes for our program to run has reduced by about 3 seconds. So it took about 4.22 seconds for the program to complete successfully. Now it's still remaining one more, and that should be okay. Finding MEX with stream. So finding MEX with stream has to do with input stream readers and output stream reader. So what I did, instead of using our normal scanner class to read values from the input source, we are using a buffered reader for this. And instead of also using our system.add.println to write the values to the console at the end of the day, we are using a writer object for this, a buffer writer that is being created, with an output stream writer. Sorry for that. So I'll Control A the whole of this, and Control C, and right here I'm going to paste it again one more time, and I'll submit the code. Okay, now our solution is accepted. Just scroll down, and it took 2.49 seconds for the program to get completed against all the test kits. So the whole idea of these different tests is just to show you how the different libraries that we make use of can affect the flow and the efficiency of a program, can affect not the flow but the time efficiency and scalability most times of a program. So you can see that in this case, it seems the buffered reader is faster than is faster in reading inputs from an input source than the use of the scanner object. So with that, we have come to the end of this beautiful episode. And please, if you are yet to subscribe to this channel, do so. Give this video a thumbs up and also click that bell icon. I'll catch you in the next one. Peace out.